Oh, hi guys, my name is Nikolai Milovanov and now I'll show you how netTransformer works. For the purpose I have built a custom topology in Dynamips. It consists of 10 routers. Each one of them is 3725 and one of them, R1, is bridged to my Ethernet network here at home. So the scenario is first we will discover that part of the network and this part will be shut down. Then we will do a second discovery and we will discover also those three routers and we will perform a network diff. Cool, so let's start the software. So that's how it looks like. I'll make a new project. It works with projects and it has two kinds of project types, SNMP Discoverer and BGP peering map. The SNMP Discoverer has been built in order to discover SNMP enabled IP networks. The BGP peering map again uses SNMP, but it discovers only the BGP peering of a BGP enabled routers. So demo 1, 2, 3. So once we do the project, we have to configure the resources, or we have to tell the software how to connect to the network. I think I have to update my SNMP communities. So we have Cisco devices, so I'll update also that one. It uses a two-stage process, so I'll put this one like this. The two-stage process actually uses first the default SNMP resource in order to get the device name and to determine the model of the device, and then we use this one or one of those, whatever is matched, in order to obtain more data from the device. Okay, I think now we are ready to start. I hope so. So fingers crossed. I have put it actually in debug mode, so basically we'll be able to see the whole kind of output. See that actually the device is responding pretty slow because my laptop, which is next to me, is quite overloaded and from those 10 routers. So the process continues. It will discover and discover. In the meanwhile, since we already got to discover the devices, I think we can open actually the graph that has been created. So it's in version 1 folder. You have to select this guy and you see the current kind of a network. As the discovery progresses, we will see more and more devices, so the software is able to do such things. Yeah, you can see another one has came. So I want to show you first how that stuff actually works. What do we get from the device? So when you click on a device, you have a graph data management where you can see the device XML. This device centric model obtained from the device to SNMP. You see this is a structured XML and you can query it through HexPath without any kind of an issue. It has some device here, then some interfaces. Under the interfaces you might have another objects like IP addresses or neighbors. This is a neighbor, for example. It has been discovered through those three methods that we already know: neighbor port, neighbor IP address, neighbor host name, and neighbor device type. So let's see, maybe they get more. Yeah. So actually, as the discovery process progresses, you see that we are discovering more and more devices. We can move them just want to show some of the filtering capabilities of the software. For example, we can select one of them like this and redraw the network on let's say 2 hops away. Yeah, maybe we can do it on 4 hops away. There is some animation, not very good, but it always tries to put the selected router in the middle. So maybe let's check out the discovery. Is it still running? Yes, I think it has finished. So this is our initial network topology that has been discovered. I just also want to quickly show you some stuff. So for example, we can select one device and we can do we can get various reports like device neighbors will show us information about the neighbors of the device and the discovery methods that were used in order to discover them. Also local IP, neighbor IPs, things like that. Another interesting thing might be the connect. You can connect with the Java console to the device through SSH. So that's how it works. Very slow, it's dynamic thing. Anyway, we have also graph tools like those. We can, for example, choose a different layout. Can choose a circle layout and other things. We have the ranking algorithms. Basically, this will give us the rank of the nodes in the network. So here I can tell that if I kill R5, definitely the damage on my network will be the biggest possible. Anyway, let's return to our official graph layout, and I want to do another discovery of the same network, but prior to that I will just power up the 3 additional routers that I have stopped, R4, R7 and R8. Yeah, so you see, maybe here the other laptop it starts to whirl. So let's start another discovery. Hope I'll start from that end, or maybe from the other end. Let me check if the device is running. Not yet. So maybe we have to wait a little bit for the network to come up. Okay, I see that the OSPF process has converged, so actually I can start the discovery this time from the let's start from here, but okay, we can start it from wherever else in the network we want. In the meanwhile, when this one is still running, I can show you also some cool stuff. So software supports filters based on the metadata of the nodes. So for example, if you want to see only the OSPF part of the network, we can do it. See, it has filtered only that nodes that have OSPF on them and those links that were built with that discovery protocol or ISIS. I think we have only just 2 of them at the moment. Here we don't have BGP. Yeah, we can filter also on CDP, I believe. So I know that R10 doesn't have CDP, so you see that actually R10 is not here. We can do also like this. We can open a new tab And in this tab we see actually one filter, in that tab another filter. Another cool feature, at least for me as a network engineer, is the fact that I can apply a template of a device. This works like this. I choose not activation and I select a template. For example, I can put that one. Hope it will open the telnet connection. I know that it's slow and I know that the machine is very heavily. But yeah, I think it did so. You see actually the command that it has put on the device. Guess we can also connect like this. So actually this was the command that I have applied. It was that one. Cool. So now I think we almost over with this demo. I think this discovery is still running. It has discovered 7 devices, but I know that there are 10. So let's wait a little bit for it. Meanwhile, I can show you what could be configured on the discoverer. So this is the config. It looks like this. So it has several device sections. General is the default one. When we do not know the type of the device, we use that one, and we can customize it based on what kind of protocols and SNMP we would like to extract from the network. For example, we have this one for Cisco. Here you see quite a lot of voids that are Cisco proprietary. Here is for Huawei and so on. It's interesting to say that there are also stop criteria of the discoverer. So for example, if we want the discoverer to not go to 72.16 network, we should just enable that kind of a rule. It works as a regex. Or if we don't want the discoverer to discover, for example, all the nodes that are in their name, so like are in the beginning, you should enable such kind of a rule. So this is actually the configuration. Let's see. Oh, it's still discovering that kind of a device. Let's wait a little bit. But anyway, in the meanwhile, we can again open the new version of the discovery that has been built. See that we already are getting more and more devices, like R4 is there, R8 is there, and I believe we should also get R7 once this one finishes. Yeah, maybe here we can try to show a bit better. No, it didn't, but it should at least, when R4 is up, we should see something better from the network. So I just want to show that there are some tooltips that are shown here when you go to the links, and there are some that are shown when you go on the notes. And oh, I think I showed you quite a lot of stuff. Let's just check that this one finished. Yes, it did, but why it... Okay, this is the right one, so it has discovered this time 10 devices. I'll do this time a diff between a version 1 and version 2. So I should do it like this. So yes, in a second we have to see the new version. Yeah. So here it is. When we select the diff filter, we will see actually that we have some issue actually. Yeah. In the second, we have here some nodes that are added and some links that are added. These are 4 guys has appeared in the network, and those 2, therefore they have those green circles around them. But at the same time it looks like we get a problem. Like maybe when I started way too many routers on my laptop, this guy didn't answer the second time, and it was removed from the graph. Also that link, yeah, that edge has disappeared. So okay, that was the version diff or the network diff, and this is the end of my demo. I think I didn't show you only one thing actually. Maybe let's show it also. When we activate something in the network, when we execute a template on a device, we can do it on one device, but we can also do it on multiple devices like this. So if I choose like not activation, you see that it will come to the first device. I mean, I can choose a template, and then it will go to the second device. I can choose another template or the same, doesn't matter, and so on until we finish all the devices. Then this is really the last stuff. We can activate devices on the network, but we can also do it on a path in the network, like this kind. So if you ask us for B node, I'll put R8. It will first draw the path, and then the software will emulate the path and will position always you on the active node, and again you can choose a template. So that was it. Thank you for your time. This was my demo. It didn't work perfectly well, but with virtual devices, that's the reality. Thank you again for your time. Bye bye.